In this video, we're going to start looking at solving inequalities with graphical methods. In core 3, you might have done a bit of this. Generally, they were equal to. In this case, we're going to do inequalities. So in this one, we've got the modulus, the absolute value of x minus 6 is strictly greater than 6x. All I'm going to do is draw two different graphs. I'm going to draw the graph of y is equal to 6x and y is equal to x minus 6. And that's a modulus of x minus 6. I appreciate that these can be solved algebraically, but in this particular section we're expected to be able to graph them. So if I do that, let's first consider this right here. Y is equal to 6x is a steep line, and that's going to be going through the origin, and that'll look something, give or take, like so. In fact, we'll make it look a little steeper than that, as we're going to put the modulus of x minus 6 on. The line, now x minus 6, would have originally done the following. We would have had something that would have gone, in fact that's not going to be a good colour to use, is it? Let's pick this one. It would have originally gone through this point here, and we would have had a y-intercept of minus 6, and we would have gone up there, and it would have continued here. What it does, obviously that would be straight, let's just make that a little straighter. When we have the modulus, we end up now reflecting in the x-axis. So with this one, now what we would have is the following. We're going to have, and let's put this on like so, let's grab that one. The modulus of x minus 6 is going to be a reflection like so. So we can now draw that on there. Okay, and we'll get rid of these ones, and that's what it's going to look like. So this point right here, okay, that point is going to be 6, 0, as that's where y is 0, and this point is going to be 0, 6. It used to be, if it was just a standard y equals x minus 6, it would have been down here at negative 6. What we need to consider is when this line, the modulus, is greater than 6x. So we find the point of intersection. If we look at this, we've got the negative modulus branch. So we take the negative of this, and that's going to be minus x plus 6. And that must be equal to this line right here, which is 6x. Adding the x to both sides, 6 is going to be equal to 7x. 6 over 7 is equal to x. So this point where they meet is where x is equal to 6 over 7. Therefore, what we're interested in is when the modulus is greater than the line, and we can quite clearly see that it's going to be this side right here. As soon as we go to the right of 6 over 7, the modulus is going to be below this line. So what we can now say is that this particular inequality is satisfied when 6 over 7 is strictly greater than x, and that's our answer. Okay, let's do another one. T minus 3, and that's the modulus of it, is strictly greater than t squared. So let's sketch these up. Again, we'll just have some basic axes. If we do t squared, we know that's going to be a parabola, and that will look something, give or take, like so. So we're going to have a parabola now, and that will come through, and then it will go up like so. The modulus of t minus 3, if we again consider the original curve, what we're going to have is the following. We will have, and let's get a line, it will look something like so. Okay, it'll have a gradient of 1, and it will cut the x-axis at 3 and the y-axis at minus 3. The modulus of this, though, will be now from here, and then we will bounce off, we will be reflecting in the x-axis, and we will come up like so. So let's get rid of the old one and put this on. If you want to leave that old one on, you can simply put a dotted line. So this point right here is going to be now 3, 0. This point is going to be 0, 3. We can see again that we've got 2 points of intersection on the parabola. We've got 1 now to the left of 0, and we've got 1 to the right of 0, but they both fall where our modulus function is negative. Therefore, what we can do is say the following. We can say minus t plus 3 will be equal to t squared. Rearranging, t squared plus t minus 3 is going to be equal to 0. This will not factor, so we're going to have to either use the quadratic equation or complete the square. So I'm going to complete the square. So t plus 1/2 all squared minus 1/4. And then if I put these into quarters, we're going to have minus 12 quarters. And that's equal to 0. Solving, t is going to be equal to minus 1/2 plus or minus the square root of 13 over 2. So what we have then is this point right here is going to be minus 1/2 minus root 13 over 2. And this one is going to be now minus 1/2 plus the root of 13 over 2. We are interested in when this line is bigger, and we can quite clearly see that that happens right here, and it's in this point from here to here. So what we can say for this inequality to be satisfied is that t is going to be strictly greater than, and we can just combine this fraction if we want, minus 1 minus root 13 over 2, yet in turn is strictly less than minus 1 plus root 13 over 2. So by that I'm assuming that you can solve quadratics and you can picture where we're now above the line. And again, you can look at doing this algebraically if you want, but the whole point of this is that we can do it graphically. Okay, let's look at this one. We've got now the modulus of x minus 2 multiplied by x plus 6 is strictly less than 9. So if we sketch this up, what's this going to look like? This is going to be a parabola. We're going to have a solution at positive 2 and negative 6. So if we put these on just here, so that's going to be, now we'll do that as negative 6 and that one as positive 2. What we'll get then, this is a positive parabola and it'll come down like so, but as soon as it hits the x-axis, we call these cusps, it's going to bounce back. So what we're going to end up having now is the following scenario. And it's going to come round and it's going to do something, give or take, like so. This point right here is going to be minus 6, and we can put 0. And this point right here is going to be 2, 0. A key part of this now is to appreciate that before the y-intercept would have been at minus 12. That therefore means that this is now at positive 12. And that's key for solving our next bit, especially graphically. We could see that if we come down here, we would have had minus 12. Therefore, this line, and that is a constant, can be put on, and we will put that just there, and it's going to look something like so. Might be slightly higher, okay? Remember, this is the line now, y is equal to 9. So let's have a look at what we've got. Y is equal to 9. If we consider this, we've now got, this is a positive parabola, this is a positive parabola, so we've got two solutions on the positive and also two solutions on the negative. So let's first take the positive. If I take the positive of the modulus here, we're going to have x squared, we're going to have plus 4x minus 12 is going to be equal to 9. Rearranging, we're going to have x squared plus 4x, and then we're going to have minus 21 is equal to 0. That looks like it'll factor x plus 7, and then we're going to have, what's that going to be, x minus 3. So we can say now that this point where the parabola is positive, this point right here is going to be where x is equal to minus 7, that's that one just there, and this one right here is when x is equal to positive 3. If we now consider these two solutions, this is where the parabola is negative. So solving, we're going to have negative x squared, negative 4x, and then we're going to have plus 9 is going to be equal to, plus 12 is going to be equal to 9. So rearranging, setting the left hand side to 0, we can have x squared plus 4x, and then subtracting 12 from both sides, we're going to have minus 3. So what do we end up with? Let's just get that. That isn't going to factor. So we again need to either complete the square or use the quadratic equation. I'll complete the square. X plus 2 all squared. And then what we're going to have now is the following. We're going to have x plus 2 all squared minus 4, and then we can have the minus 3, and that's equal to 0. So we can say x is going to be equal to minus 2 plus or minus root 7. And again, I'm assuming that you can solve quadratic equations. So this one now is going to be minus 2 minus root 7, and this one is going to be minus 2 plus root 7. So that's that solution there, and that's that solution there. What we're interested in is when this is all less than 9. We can see that occurs, and I'll just shade this on. That occurs at this point right here, and then this point right here. That is when this is below 9. So what we can say then is that x is going to be strictly greater than minus 7, yet in turn strictly greater than minus 2 minus root 7, or we can say x is going to be greater than minus 2 plus root 7, yet in turn strictly less than now positive 3. So these are the values that satisfy our inequality. So nice and straightforward-ish, and hopefully that gives you some idea. Again, I appreciate they can be done algebraically, but we're expected to be able to do them graphically. So there we go. You'll be expected, if you're asked to do this in an exam, basic sketch, show the points of intersection, consider your different options, and then solve from there.